Hello students, this is the fifth video on rate measure. In this video also, I am continuing the examples of exercise 6.1 and these examples are very important for your examination purpose. First one, a balloon which always remains spherical on inflation is being inflated by pumping in 900 cubic centimeters of gas per second. Find the rate at which the radius of the balloon increases when the radius is 15 centimeters. Here they have taken a balloon means we are constantly putting the air into it. When the air is put into it, then its radius will be increasing. And it is containing something. It is containing the air in it means this will be the sphere shape. Okay, the balloon will be the sphere shape. Okay, now a balloon which always remains spherical means it's always in the circular shape like this. So the volume of a sphere is increasing at the rate of what? 900 cubic centimeters per second, because they are pumping in 900 cc per second of gas into it. So then its radius is increasing and its surface area is also increasing. Find the rate at which the radius of the balloon is increasing. dr upon dt you have to find out. When the radius is 15 centimeters, because when that balloon, it was around 15 centimeters, they have started pumping in the gas at the rate of 900 cubic cc per second. They are putting the gas into it means dV by dt is 900 cc per second. Now, I consider the formula for volume of a sphere. Volume of a sphere, V is 4 by 3 pi r cube. Differentiate this with respect to t. dV by dt is 4 by 3 pi is constant. R cube derivative, r raised to n into r raised to n minus 1. So it is 3 into r square. Then dr upon dt. These three, that 3 get cancelled. I get 4 pi r square into dr upon dt. Then I know dV by dt is 900 because the gas is put into it at the rate of means dV by dt is 900 cc. Then when the radius has of radius 15 centimeter means I will put r is 15 square. Then dr upon dt is equal to I1. So I'll take this to the left hand side. This becomes the denominator for the left hand side. I get it as 0.9 centimeters per second because the radius is increasing at the rate of means for 0.95 centimeters per second is the rate at which the radius of the balloon is increasing. Okay. Now I consider one more example, similar type. A balloon which always remains spherical has a variable radius. Find the rate at which its volume is increasing with the radius when the latter is 10 centimeters. Here they have asked you to find out dV by dr. Volume of a sphere is 4 by 3 pi r cube. Differentiate this with respect to r here because volume is increasing with respect to radius they have asked. So differentiate with respect to r on both sides. So it is r cube derivative will be just 3r square. I will not multiply it by dr upon dt because I am differentiating this with respect to r. This is very important. Now, when the radius of that balloon was 10 centimeters means this r is replaced by 10 centimeters. So I get it as 4 pi into 10 square. That is 400 pi cubic cc per second. Now, I consider one more important example. A ladder 5 meters long is leaning against a wall. The bottom of the ladder is pulled away from the wall at the rate of 2 centimeters per second. How fast is its height on the wall decreasing when the foot of the ladder is 4 meters away from the wall? This is an interesting example. Suppose always you will keep the ladder in the slanting position like this. Okay, and this is the ground and a ladder 5 meters long means the length of this ladder is 5 meters. Okay, now you note down the units here. 5 meters long ladder is there and the wall is like this. It is leaning against the wall, they told. Okay, and it is pulled along the ground, they asked. The ladder, the bottom of the ladder, this is the bottom of the ladder. It is pulled along the ground away from the wall. This is our wall means the ladder is pulled away from the wall. When you are pulling it like this, then the height of this ladder towards the wall will be decreasing like this. Is it not? Here you can see AC is the ladder. AC is the ladder and AB is the wall. Then BC is the distance between the bottom of the ladder and the wall. Okay. Let X be the distance between the wall and the foot of the ladder. This is the foot of the ladder. Now, why a foot of the ladder is moving away from the wall? It is moving away like this. Since the ladder length is fixed, when you move it away from the wall towards like this, then the height of that ladder towards the wall will be decreasing. This is why. Okay, dy by dt, dx upon dt. Then they are given how fast is its height on the wall decreasing. Dy upon dt is how much when the foot of the ladder is 4 meters away from the wall. When the foot of the ladder is 4 meters and it is moving in this direction, means dx upon dt they have told. Dx upon dt they have given it as 2 centimeters per second. Okay. Now you note the units here. The ladder length is in terms of meters and the rate at which these are changing it runs to the centimeters. So the first thing what we have to do is we have to convert either the changes into meters or the length of the ladder into centimeters. Let me convert the length of the ladder into centimeters only. Okay. Dx upon dt is 2 centimeters per second. And then AC, the length of this is 5 meters. I will convert it into centimeters as 500 centimeters. Now, I can build the relation between X and Y here because according to Pythagoras theorem, in this right angle triangle ABC, I can say AB square plus BC square is equal to AC square. So AB will be the height of the wall and this ladder will be decreasing, means when it is decreasing and reaches some point E here. Okay. So let me write the Pythagoras theorem. According to Pythagoras theorem, height of the square of that hypotenuse is equal to the AB square plus BC square. It is X square plus Y square. Now, let me find out when X is 400 centimeters, what is the Y square? Because they have been given, this is 4 meters. When the feet of the ladder, here you can see, when the feet of the ladder is 4 meters away from the wall, when the foot of the ladder is 4 meters away from the wall, how fast is the height towards the wall decreasing is asked. So for that, first I find out what is Y using the Pythagoras theorem. 500 square is equal to 400 square plus Y square. Y square is 90,000, means Y will be 300 centimeters. Now I have to find out dy upon dt. So I make use of this formula. In AC, I will put it as 500 square. Then differentiate this with respect to t on both sides. Here this is a constant, means it becomes 0. D by dt of x square, it will be 2x into dx upon dt plus y square derivative is 2y into dy upon dt. 2x upon dx, 2x into dx upon dt is equal to minus 2y into dy upon dt. Substitute when x is 400 centimeters and the tip of foot of that ladder is pulled away from the ground at the rate of 2 centimeters per second, means I'll substitute all the things. Then 2 into y, just now we have found it is 300. So at what rate is the height of that ladder towards the wall decreasing? It is decreasing at the rate of 8 by 3 centimeters per second. Okay. I hope you have understood. Okay. Now, I consider one more example. This is also an important example. A particle moves along the curve 6y is equal to x cube plus 2. Suppose x cube plus 2 is a curve like this. The point on this curve is increasing at some rate. At what rate it is increasing? Find the points on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. Suppose the coordinates of any particle on the curve is x comma y. Y coordinate is changing 8 times as fast as the x coordinate. Y is equal to 8x they have given. Okay. Now I have to find out dy upon dt. The equation of curve is 6y is equal to x cube plus 2. When I differentiate this, and what they have given, dy by dt is 8 times of dx upon dt, because y coordinate is changing 8 times as fast as the x coordinate, means the rate at which y and x are changing is given. So dy by dt is 8 dx upon dt. Next is, I will differentiate the equation of curve with respect to time. Okay, then I will express dy by dt in terms of dx only, because I know dy by dt is 8 times of dx by dt. So dy by dt is substituted as 8 times of dx upon dt. X cube derivative is 3x square. Okay, because this is because. Now 6 into 8 dx upon dt is 3x square into dx upon dt. Then 3x square is 48, means x square is 16. X is equal to plus or minus 4. So the x coordinate of this point is 4. Then I can find out its corresponding y coordinate by substituting that value of x in the equation of curve. Equation of curve is 6y is equal to x cube plus 2. I will put x is 4, means I will get the y coordinate as 1 minus 31 by 3. Let me simplify. Thus, that point is the coordinates of that point, of that particle. Okay. In the next video, we shall see some more examples. Thank you.